Alright guys, the purpose of this video, this will be the final video in the statistics training video package, but the purpose of this video, that actually sounded weird, but the purpose of this video is to show how we conduct inference for a t-test and a one-prop z-test using R. It turns out it's very easy, much simpler than using the graphing calculator, or at least in my opinion it is. So I'll show you some things, and then in the end I have a data set that I found that has some house data that I'll illustrate a couple of things on. Alright gang, let's first of all, when teaching R to students, one of the first things that you've got to kind of the first hurdle, if you will, to get over is to set your working directory. And I know I've covered this in a previous video, but it still seems to create issues. So let me go over it one more time very quickly. First thing we need to do is get the working directory. Why this is important, if you're in the initial stages of trying to set your working directory, is it gives you the form that your working directory is set in. So I like for my working directory to be the desktop. It doesn't have to be, but that's the way I like it. So if I'm going to set my working directory here, I'm going to use the form of the current working directory and then just type desktop at the end. Okay, now let me get out of this and let's go back to the handout. And the first thing that we've done here is we've got the confidence interval issue with the mean emission level for this newly designed engine. And then if you'll come on down, you'll see that for the same data, we have the question that's appropriate for a test of hypothesis. So we want to test the claim that the average or the mean emission level is 20 using these 10 measurements. Also up here we wanted to calculate the 95% confidence interval. Well, if I was going to do this problem, what I would do is I would copy and paste the data, and then I would come over to R, and I'm going to set it up, you know, something that kind of makes sense. I don't know. Emission level, and I'm going to use what I call the C function, and I'm just going to paste my data in there. Now guys, you got to be careful with this and, because R isn't going to like that. Alright, so I'm going to enter my data as EMLEV. Now the first thing I'd want to do is make sure I got all of my data, and make sure I didn't do something goofy in terms of copying and pasting, and I have 10, which is cool. Okay, so the first thing, let's construct or conduct a test of hypothesis. So I think we want to not only get a 95% confidence interval, we want to test that the population mean is 20 at the 0.05 level of significance. Now guys, notice there's no reference to whether we want to test greater than, less than, or not equal to. So if there's no reference, the default is always not equal to. So guys, it's going to be an easy thing to do. So we're just going to run a t-test, and I want to run this on the emission level. And I want to run this on testing the population mean is equal to 20. And I want to run my confidence level just to point something out here. I know I don't want to run a 0.90 confidence level, but yeah, I'll tell you what. Let's go ahead first time and just run this as the default. Okay. So if I run my t-test, you'll see that my test statistic is negative 3.0016. I have 9 degrees of freedom, and my p-value is 0.01492. My 95% confidence interval is provided, which is the default. And so our claim, or I'm sorry, our decision here would be clearly reject the null. So we would conclude that the true mean is not equal to 20. It looks like to me from the confidence interval that mu is somewhere between 15 and 19.3. So I'm much more comfortable making the conclusion that the mean emission level for all of these cars is somewhere between 15.04 and 19.30. Now, let's change things up a little bit. What if our intent was to okay, I want to break this up in bits and pieces. I was going to do everything in one, but let's back up a little bit. What if I want to do the same thing? Still want to test mu equal to 20, but I want to conduct a one-tail test of less than. Well, guys, this is really easy to do. All I have to do is run less than. So you can see up here the alternative hypothesis, the true mean is not equal to, which is the default if you don't include the prompt of alternative. But if you include the prompt of alternative, it's going to test that. Now guys, your test statistic and your degrees of freedom will always be the same, but notice that the p-value changes because you put all of your rejection region in one particular tail. Your 95% confidence interval would run from negative infinity to 18.89. I do not like the way that R presents confidence intervals when we do a one-tail or two-tail test. So guys, if I was going to run a one-tail test, I would run the two-tail test first, get the accurate confidence interval, and then conducting the test of hypothesis, I would run the alternative equal less. If I wanted to run the alternative as greater than, it's probably pretty clear to you what I would do here. I would run greater than. Okay. Now, what if I wanted to do all this, but I wanted to get a confidence level different than the default of 0.95? Well, it turns out that's easy to do also. So I would just run confidence level equal whatever we want, 0.90. So guys, what you'll see there, it's still carried out the same okay, so the true mean not equal to, but we've run a 90% confidence interval from 15.44 to 18.89. So notice that it differs than what we got up here for the 95% confidence interval. But notice the p-value is the same as you would expect it to be. Okay, so again, running a t-interval and a t-test. There are some packages that you can install. I forget the name of it. It's like RMISC or something, R miscellaneous or something like that, where you can actually just get a confidence interval. But I don't think it's a big deal to if you need a confidence interval, to just run the t-test and get it as kind of just kind of an added extra. All right, the other problem that we had in this situation, or in this handout right here, was for the confidence interval of the percentage of households that have high-speed internet service. And we've examined 150 households excuse me, and found that 58 have high-speed internet service. Now, two things going on here. First of all, we want to calculate the 90% confidence interval, but we also want to test the claim that the percentage of households with high-speed internet is 30%. Well, it turns out in R there's a handy dandy feature that does that for us, and it's called the prop test. The first thing we enter in prop test is our x, which is 58. The next thing we enter is the n, which is 150. We want to test a p-value of 0.30, and we want a confidence level equal to 0.90. Now this is going to run a two-tailed test. Not equal to is the alternative hypothesis. And you've got a little, well, let me just go ahead here. The first thing you're going to see is you're going to get your output's going to be a little different. And what this is going to give you, it's going to give you your chi-squared statistic. And when you run this on your graphing calculator, you're not going to get 4.96. But if you take the square root of 4.9603, you're going to get the z statistic that's presented on the calculator. This models the one proportion z-test with the chi-square distribution. I wish it didn't. Because one proportion z-tests are at the very, very lowest elementary level in statistics, and so many students in a 1500 or a comparison class across universities across the country haven't yet studied chi-square. So I wish it didn't do this, but it does. Just pointed out to students that the test statistic, you have to take the square root of the chi-square to get the z value. Okay. Just like before, if you just are comfortable running a two-tailed test, and you want the default 95% confidence interval, then this is all you got to do. Now, guys, next thing I want to show you is I've got a data set here which I kind of like. I don't know. And let's say that we look at something like this, and what I would have students do is get in groups and come up with a question that would be appropriate for a t-test and one that would be appropriate for a one prop z-test. And I think this is good because it kind of forces them to understand that t-test deals with quantitative data and a one prop z-test deals with categorical data. So something that your students may come up with, I don't know, is let's test that the average area, I guess this is the square footage of the house that's being sold, let's test the claim that the area is equal to 2,000. Let's also test the claim that 50% of the houses in this area sell. Alright, so we got it. So two things going on here. Let's test the claim that the area is 2,000. And secondly, let's test the claim that 50% of the houses sell. 0 is coded not sell, and 1 is coded as sell. Okay? Now, the first thing I'd want you to do here is I'd want you to come in and save this as a CSV file. So I want to save this as house. I want to save it on my desktop, but I want to save it as CSV. Okay? So I'm going to save it. I want to continue, and then I want to close it down. It's going to ask if you want to save it again. There's no reason to do that because we already have it saved on our desktop. So you'll now see that I have a file, house, which is in CSV on my desktop, and it's going to make it very, very easy for me in R to go get that. So I'm just going to call this data, and I want to do read CSV, house CSV. Now I see a lot of people that name their data sets crazy things, and guys, keep it. I usually try to keep my data set all caps, and I try to keep it something 3, 4, or 5 letters. Now the next thing I've always got to do is I've always got to attach my data. And then I want to look at the data, or I'm sorry, the variables that are included. Now, first thing I want to do is I want to test the claim that the area is 2,000. So guys, I'm going to run a t-test. I want area, mu equal 2,000. And I'm okay with that. I'm okay with the confidence level being the default of 0.95. I'm also okay testing at two-tail. So my alternative hypothesis is not equal to. So like that, wham bam, thank you ma'am, we've got our test statistic. We have our degrees of freedom, and we have our p-value, which is greater than 0.05, which would lead us to fail to reject the null hypothesis. Notice that the 95% confidence interval is provided, and that our claim of 2,000 is included in the 95% confidence interval, validating that from this sample we don't have enough evidence to reject the claim. Now let's run a one-prop z-test on the percentage of houses that sell. Now right now sell is coded zeros and ones, and although we know that that means that it's zeros and ones stand for well, zero stands for not sell and one stands for sell, we understand that 0 and 1s are actually groups, categories. R doesn't see that. R sees 0 as absence of value. It sees 1 as 1 unit. So what we have to do there is we have to come up with another variable, and I'm just going to call it sell lowercase, and I want to set this factor, set the cell as it currently is provided as a factor. I want it to see cell as a categorical variable. So now zeros and ones are not seen as 0 absence of value and 1 is 1 unit. It's seen as 0 and 1 as 2 factors. Now I want to do summary of cell, and you'll see that I have 24 zeros and I have 16 ones. So I want to run a one prop test. I have x equal 16. N is out of 40. And I want to test that 50% of the houses sell. Guys, I'm okay with the default of 95% confidence interval. I'm okay testing that we're running a two-tail test, not equal to. So I run this, and I look at my p-value, and it's greater than 0.05, which says I cannot reject the claim that 50% of the houses in this area that are put up for sale actually do end up selling. Got a very small sample size here. Now, sometimes you'll see that when we run a prop test, that the values won't be the same as what we get on our graphing calculator. Now, let me bring that up. I want to because you're almost certain to run into this, and students will absolutely go insane when they do something on the calculator and they get a particular answer, and then they do it on their calculator and they get something different. So let me show you how this works. It gets into something called Yates continuity correction. But as your statistics teacher, you definitely need this on your radar, so you can answer your students' questions. All right, gang. So if I was running a one prop z-test, that would come all the way down to A. No, I wouldn't. I'd go to 5. Alright, so I want to test 0.50 from my data of what, 16 out of 40? 16 out of 40, so. And I want to test not equal to. And I can go calculate. And you know what? We get a little bit different stuff. We get the same sample estimate. The sample estimate of 0.4 for our population proportion. But we get a little bit different z-value. And we get a different p-value. Now let's go back over to R. Now first of all, what I want to show you here is that our sample estimate 0.4 is below what we're testing. So we had to expect a negative z as we got on the calculator. You can point out to your students that 1.225 gives you the... Okay, what's going on here? Oh, okay. Let's run this. Let's run the prop test. X equals 16, n equal 40, p equal 0.50, and correct equal false. All right, when we run correct equal false, and now let's run the square root of 1.6. You're going to see that everything is going to match up with your calculator. Now this gets into something called a Yates continuity correction. Your calculator runs without the continuity correction. Which one's right, which one's wrong? You know, I don't really think that's something that you need to get in with your students at the 1500 level. If we can just be consistent and run things as presented on the calculator and as presented on R, I'll be a happy camper. But notice when you run without continuity correction that your 95% confidence interval changes. So if students would have run the one prop z interval over here, they would have they would not get this. They would get the answer right here that's presented with the continuity correction. So guys, you can see that that running t-test and one prop z-test on R, very, very, very easy to do. Guys, that's it. That's all this video. Wish you the best. Don't hesitate to contact me if you have any questions. If you'd like a guest speaker someday, and just to break things up, give me a yell and I'll come to your high school and maybe present a lecture for you, or maybe Heather will too. Guys, that's the end. Have a good one.